Good morning and welcome everyone. It's me Manish Ghimire teaching you science subject from class 10. And today too I am here with the same topic that we started yesterday, acids, base and salt. Yesterday we completed discussion on it about its category on strength basis, on from where they are obtained, means what are their sources and others. We come to know that some acids are strong in nature, some acids are weak in nature. Strong acids conduct electricity very well because they produce large concentration of hydrogen ion in aqueous solution. Likewise, weak acids are just opposite of it. I mean to say they produce less concentration of hydrogen ion in aqueous solution, making it poor conductor of electricity. Today, let us move some more further. It's about physical properties of acids. Most of the acids, say more than 98% of acids, maybe 99 too, because only few acids are non-sour in nature. So, most of the acids are sour in taste. Most of the acids are sour in taste. Leaving behind some others which are non-sour. I mentioned you the examples like boric acid, stearic acid, salicylic acid. These acids are non-sour in taste. So, you can write some exceptional cases of these three acids here. Otherwise, all them are sour in nature. Second, physical properties. Mineral acids are corrosive in nature. They can cause burning sensation in our skin, leaving behind some harmful cancerous effect also. They can burn your skin for a whole lifetime, which recovery is not that easy. That is why we can say most of the acids are corrosive in nature and produce burning sensation in our skin. But some others which are organic, which are edible, are not harmful to us. In fact, they are most necessary nutrients or nutrients material. We need vitamin C that is obtained from acids. That is why some acids are edible, we can consume, whereas some others are not. They are dangerous and corrosive in nature. You can write that here. Most of the acids, say mineral acids, most of the mineral acids are harmful and corrosive in nature. Means they can cause burning sensation in our skin, whereas others may be useful in terms of human health. Otherwise, all the acids are useful because they are somehow useful in various industries. They have wide range of application there. I mean to say, in terms of health basis, some acids are more useful because they contain nutrients required to our body and vitamins as well. So, you can write corrosive in nature, whereas others may be useful and very much required to our health. Because acids build immunity system also in our body. Likewise, another physical property I may drop this, I think you note it down. Let us discuss acids on the basis how they show change with indicators. You can see the third points there. Acids change blue litmus paper and methyl orange into red color. Blue litmus paper and methyl orange are both ordinary indicators that are very common in use in chemical lab. But acid does not show any change with phenolphthalein. Means phenolphthalein is naturally colorless. When acid is put on phenolphthalein, or when some few drops of acid and phenolphthaleins are mixed together, no change is observed. That is why we say acid brings change in color in blue litmus paper and methyl orange, whereas no effect is observed when it is treated with phenolphthalein and of course red litmus paper. This you can include as a third, look at the screen once, this you can include as a third point under the physical properties of acid. So let us move forward. We completed that. Now it's a turn to read about chemical properties of acids. You can see there the very first point, reaction with reactive metals. This is most important chemical reactions that you need to understand. Acids show various chemical changes with different chemical substances and reactants. The very first point there is very first chemical property, reaction of acid with reactive metals. You can see here, with reactive metal. How acid responds with reactive metals? Let us find out. Let us take an example of sodium. Sodium is one of the very reactive metals. When it is treated with dilute acid, say dilute hydrochloric acid, that is HCl, hydrogen gas is released. Hydrogen gas is liberated. See the chemical reaction. Look, whenever reactive metal is treated with dilute acid, salt, corresponding salt is formed along with the release of hydrogen gas. Here I have pointed arrow up. It indicates that this is gas. Since hydrogen gas is very light, it goes up as soon as it is released in the chemical reaction. So this is the reaction of acid with metals. Let us take one more example. This is potassium, another very reactive metals. You must know this reactive metal belong to alkali group in modern periodic table. So it is very reactive metals. When it is treated with say dilute sulfuric acid, means H2SO4, what does it form? Again, the main base is same. Whenever acid is treated with dilute acid, whenever acid is treated with reactive metals, hydrogen gas is formed for sure. So here to the product is quite same, hydrogen gas, but salt would be corresponding salt. What kind of metals we have chosen and with what acids we have treated, that determines what kind of salt is going to be formed. So here it is K2SO4. This is the potassium sulfate. Means potassium with dilute sulfuric acid would form potassium sulfate and hydrogen gas. So how we can find that potassium sulfate is going to be formed here? Let me make you easy on that. Actually, hydrogen gas is obviously formed from H2, right? This is sulfuric acid, and potassium displaces hydrogen gas from sulfuric acid. Means hydrogen ion is displaced by electropositive metal. It is more electropositive than hydrogen. So hydrogen get displaced. And what is left behind then? There is left behind potassium and sulfate radical to react together, to be combined together. And you must know, potassium valency 1 and sulfate valency 2. And you must know the mechanism of making a crisscross between two different radicals or elements. We can make a crisscross between them. The valency 2 comes down of K like this, and this one goes down of SO4. This is not much important, so you don't need to write actually. It does not have much value here in chemical reaction, especially in crisscross. So what is the result? Of course, on combination K2 SO4. This is how corresponding salt is formed in given chemical reaction. So I think you come to know about how to make a chemical reaction, but the major fact you need to understand here is, whenever dilute acids are treated with metals, hydrogen gas is formed along with corresponding salt. So let us move to another chemical reaction. In the screen you can see, look, in second number chemical reaction, there is mentioned acid dissolves in water and produce hydrogen ions. See the reaction there. Acids undergo ionization in water and produce hydrogen ions. Let us see the board. Acids undergo ionization in aqueous solution and produce hydrogen ion. This is unique. This is most unique feature of acid that comes under chemical properties. See, let us take one example. Again, hydrochloric acid. When it is dissolved in water, whenever substances or compounds are dissolved in water, we always take double arrow chemical reaction, because this is always reversible in nature. So HCl in aqueous solution breaks down into opposite ions. Look, this is the result. Hydrogen ion and chloride ions are formed when hydrochloric acid is decomposed by dissolving into an aqueous solution. This is the result. Likewise, sulfuric acid, you can say sulfuric acid in aqueous solution produces similar hydrogen ion and sulfate ions. Look, this is how sulfuric acid is dissolved and produces hydrogen ions. Let me take one more example of nitric acid. Here the same, nitric acid. All these acids are mineral acid, you need to understand. What does it form? Of course, the same hydrogen ion, and the another one is nitrate ion. So look at the common things of all. The most common thing here, you can see all these acids are producing hydrogen ion. This is the same hydrogen ion which is very reactive, immediately react with water and make hydronium ion. That hydronium ion stimulates our taste bud in the tongues and make it feel sour. That is why acids are mostly sour in taste, we say. It is the reason hidden inside what does acid release or what does it contain? It is the hydrogen ion that makes you feel sour in taste. So, one more example, let us take one organic acid CH3COOH. Look, this is your acetic acid found in vinegar, and this acid has wide range of application in providing flavor to the different foods, especially in cakes, chocolates and other food items. So, it is of maximum use in the current real world. So, how it breaks down in aqueous solution? See, though it is weak in nature, it breaks down forming these two opposite ions. Anyway, hydrogen ion is always CO. So, this is the major property of acid. Now, move to third property. Look at the screen again. Let's talk about neutralization reaction. One of the most important reaction that you dealt with it since you were in class 8, I guess. One more time, neutralization chemical reaction. Last time when I taught you chemical reaction topic, there also I explained well about it. I guess you understood better there too. Today too, let us revise it one more time. Neutralization chemical reaction, the third property of acid. Neutralization chemical reaction means when acid and base of equal strengths, acid plus base, let's say, when acid and base of equal strengths are reacted together, they produce salt and water. But to be pointed out, listen, whenever acid and base of equal strength means they are equal in terms of their strength. When equal strength acids and bases are reacted together, they neutralize each other's effect, thereby producing neutral substances like salt and water. Here, salt also a neutral substance and water is always a neutral substance. They both have pH 7. That is why we call them neutral substances. They produce neither corrosive effect on our skin nor they burn our skin to give out some harmful scar and all the deposits as well. So, see, HCl is one of the mineral acid and NaOH is one of the strongest base. Look, this is acid and this is base. HCl is one of the strongest mineral acid and sodium hydroxide is one of the strongest base. When these two are reacted together, neutral substances like salt, sodium chloride and water are formed. This is sodium chloride which we use as a kitchen salt and it is very edible in nature that we need always in our daily kitchen life. And this is of course water, and both them are neutral substances. Likewise, let me take another example. One more acid, sulfuric acid. See, this is, I said yesterday, this is kingly chemical because it has wide range of application in the real world. In most of the factories it is used and it makes many chemicals dissolve in it. Moreover, it is strongest of all and it produces large concentration of hydrogen ion in solution. So when this sulfuric acid is treated with, let us take another base, potassium hydroxide, what happens? It forms potassium sulfate plus water. Look at this chemical reaction. Aren't these neutral substances? Of course, this is salt and this is water, and both them are neutral substances. So acid and base produce salt and water. Salt would always be corresponding salt. That depends on what kind of acids that we have chosen and what is the base we took. That determines what kind of corresponding salt is going to be formed. That's the fact. So this is the third chemical properties of acid. Let's find out the next. In this screen also you can see chemical reaction are well listed. Now another chemical reaction on the screen you can see reaction with metallic carbonates and bicarbonates. This comes under the last chemical property of acid, or I may include one more on that case, reaction of acids with metallic carbonates and bicarbonates. In the screen you can see whenever acid react with metallic carbonate or bicarbonate, it produces carbon dioxide gas. See here point number 4, reaction with metallic carbonate or bicarbonate. Let me first project clear idea on what metallic carbonate is and what metallic bicarbonate is. See, metallic carbonate, metallic carbonate. Let us take one metal, sodium. Carbonate means you always know it is electronegative radical, CO3. You must know valency of sodium 1 and carbonate 2 on crisscross it forms Na2CO3. Means it is one of the metallic carbonate. We call specifically sodium carbonate. Similarly, NaHCO3, it is metallic bicarbonate. And how we call it? We call it sodium bicarbonate. Likewise, this is potassium bicarbonate, this is potassium carbonate. Look, the first one is metal, second one is carbonate, so it is called metallic carbonate. See how acid reacts with them. Reaction with metallic carbonate of what? Of acid. See, let us take one acid, hydrochloric acid, one of the most well known mineral acid that is prepared from various minerals found in the earth's crust and is corrosive in nature. Of course, I said number of times, when hydrochloric acid is treated with metallic bicarbonate or metallic carbonate. Here is also, let us take Na2CO3, this is sodium carbonate. Whenever hydrogen meets oxygen somehow in a given chemical reactants, water is formed for sure. So this is an idea to remember to make how to make chemical reaction. Means whenever hydrogen and oxygen are there in reactant site, water is formed for sure. See, you can just plot water here plus. Whenever you find carbonate radical on reactant side, I said carbon dioxide gas is formed plus. Now remaining, what is left behind is salt to be formed. See, this CO3 produces carbon dioxide gas and oxygen from here, because one oxygen is left behind and hydrogen together form water. Then what is left behind? You can guess, sodium is left and